Good evening, everyone. Hello. My name is David Denton. I usually give this talk. I've given it a few times with a guy called Ivan Sanchez, who's my partner in crime. So we've done it in a few countries now, so we always give each other credit. So that's fine. This is kind of a bit of a journey story about how a project we were on transitioned from Java to Kotlin. So it was just about the things we managed to kind of what Kotlin gave us and how we managed to end up creating a kind of open source framework in the meantime. So a little about me, who the hell am I? So my name is David Denton, I'm an independent consultant. I'm currently at Bo, which is kind of a new digital bank with a conscience, is kind of, I suppose, how they're playing it. If you're interested in building a bank in Kotlin, come talk to me afterwards. Obviously, everyone's always hiring, so it's fine. I also do Kotlin training. I've been doing Kotlin since 2016-ish, before version 1 came out, so hopefully I know a bit about it. So I do some training at Skills Matter. Kind of try and do speaking. I was lucky enough to do Kotlin Conf last year, so that was really good in Amsterdam. And I do loads of open source stuff, so check me out on GitHub, and you can see my mistakes being made in almost real time. Oh, wrong way. Okay, fine, cool. So this project, as I said, is about this talk is about a project that I did at a company called Spring Nature, they're literally just next door, actually, next to the Guardian building. And it's basically, they are a massive academic publisher, and it was about the project was to deliver all of their academic content online. It's a pretty big site. It's one of the top 1,000 sites in the world. Sounds really impressive, but after the first few, it kind of really tails off. But a few tens of millions of hits today, so it's pretty respectable. They've got these various brands that they publish under, and the project was a monorepo because it's trendy. We were using Go for deployment, and we were deploying to Cloud Foundry, which is kind of like a Heroku kind of service platform thing. Okay, so that's given up. Fantastic. Okay, guess I'm using this then. Oh no, okay, fair enough. Right. Okay, so the project itself was started in Java. And after a certain amount of time, we had a load of people started wanting to use Kotlin because Kotlin was a new thing. It was like 2016. And we had some management that were quite happy to let us kind of experiment and play with new things. And Kotlin seemed to be like a really good model for developer productivity. As Marty said, it's a really nice language to work in. Even then, it had some rough edges then, but it's got really much better now. And we had our Java implementation of the service at the time. We had these kind of retrospectives every now and again about what's going well, what's not going well, and we came up with these list of problems. We were using a Mooseful HTTP model, which we found hard. We had a load of boilerplate. We had magic around routing, so this is basically web application routing. Things were a little bit hard to test, and because we were switching. We had Java and versus native Kotlin wise, sorry. And what that means is basically we were using a functional library called Totally Lazy, which is an amazing library at the time. It was written before the functional collection stuff came out in Java. And that was, as we moved into Kotlin, a lot of the method signatures are the same, so the IDEs would keep getting confused about which one we were using. So we really kind of we thought, well, we need to move towards like a real kind of Kotlin-based solution, basically. So those are the problems we're having. Hopefully, we'll see how we manage to kind of overcome them and things are a bit better. So server as a function, title of the talk, what is it? Okay, so server as a function is a 2013 white paper. It was written by a guy at Twitter called Marius Eriksson. And it basically said you can compose all distributed services out of two different types of function, or asynchronous function. One of these types was called a service, and that represents a system boundary. So a remote system boundary, and it doesn't matter what is it, incoming and outgoing system boundary, it's all symmetrical. And a filter, which you might know is middleware in other things, which is basically for modeling application agnostic kind of stuff like logging and tracing and performance and all that kind of stuff, basically. So these are the two kind of and the idea was that you could basically model all functions, all systems out of just these two types, and we'll see what those types are in a minute. So as it's Twitter has got an implementation of this. It's called Finagle. It's written in Scala. Spring Nature at the time weren't really using Scala. They used it for a bit of stuff, but people were finding it quite difficult to use. It's asynchronous. Futures are hard to developers are finding features hard to actually work with. So what we really wanted to was, we wanted something like that, but we thought, oh, we're using Kotlin, so we want to kind of come up with something ourselves if we can. So how did we do that? Right. So what we did is we ended up creating HttpHandler. HttpHandler is a incredibly simple, hopefully, incredibly simple implementation of the server as a function idea, written in pure Kotlin. It is designed to be simple. It's designed to have no dependencies. It's designed to be really, really, really fast, hopefully. And it's also designed to have no magic at all. There are various different concepts that make it up, and we'll kind of go through one by one. So first concept was just an HTTP message. What's an HTTP message? I'm sure you guys know. It's a message which serializes the HTTP standard, of course. Now HttpHandler represents these as immutable data classes. So the first point we had on our Techrospective that we had was that the request and response classes are basically immutable data objects. So what we've got here is we're creating a request object, and when we set the query object, when we set a query on it, we get back another HTTP request object with a different with the name set on it. This is important because if you're stepping through your code and you're changing your request, you might add some headers, or you're not actually mutating a thing under the covers. What you're actually doing is creating a new object every time. So if you step through the code, you can actually see exactly what the state of a particular request or response was at any particular moment in the stack. And that actually makes a massive difference when it comes to actually working out what's going on. Response, the same thing. It's just that easy to create a thing, because obviously in Kotlin you don't use the new keyword, so you just kind of get this little DSL around creating stuff. The next, and this is the most important concept in HttpHandler, was not a service. We said it wasn't a service. The thing about Finnegal is that it represents all different types of service. It's protocol agnostic, which means you can represent HTTP with it. You can represent FTP with it. You can represent SQL with it. But we're only interested in HTTP. So we renamed service to HttpHandler, and it's actually, and what does it do? Well, an HttpHandler is a function that turns an HTTP request into an HTTP response, and it's modeled as a type alias. Thank you, Marty, for explaining what a type alias was, so I don't have to do it. That's excellent. This is how it's written in Kotlin. It's kind of similar to Scala, and this is what it looks like. So what we have here is an HttpHandler, and you see that we're not creating an object because it's not an object. It is literally just a function. And in Kotlin, you don't need to actually give it. There's no new object. It's just like a lambda, basically. And so this echo handler is taking the request, and it's returning a response, and it's taking the body out of the request and returning it. So can be modeled simply as a function with absolutely no routing or gubbins, anything at all. It's literally just taking a request and returning a response. And you can see here, because the HttpHandler is a request, how do we call it? Well, we call it like a function. We pass a request into it, and we get a response back. And that's it. The next concept is called a filter. So what does a filter do? It provides pre- and post-processing on an HTTP operation. It's just a function. So this is actually, it's modeled as an interface with a single function. What it does is it takes an HttpHandler and returns another HttpHandler. And so there's nothing more to it than that. It's incredibly simple. The entire of the core of HttpHandler is about 20 lines of code, if that. And this is how it looks. Once again, we can use the niceness of Kotlin to write things in a kind of nice little DSCD type way. We've got a filter. It takes the next HttpHandler. So this is very similar to how you would do servlet filters, if you've ever seen that. It's a similar kind of mechanic. If you actually took a servlet filter I think takes a next filter and it also takes the request. And actually, this is just a mashing of those two things together because we have type aliases in Kotlin. So this filter basically can apply in a chain. So we can say Twitter filter, which takes 140 characters from the request, puts it into a new request, and then sends it through to the next thing in the chain. So what we're doing here is limiting the amount of characters that can go through to the next thing in the chain. And this is how we compose them together. We can compose it saying Twitter filter, then echo, and this returns an HttpHandler. So if you compose a filter with an HTTP handler, you get another HTTP handler which has been decorated. If you compose a filter with a filter, you get another filter, which is just the composition of those two things together. So it's quite functional in the way it kind of all sits together. Obviously, that when you're creating an HTTP framework, you also need to be able to route various traffic from one place to another, so you end up at the right handler. So we created a new concept which is called a router. What does it do? It matches an HTTP handler against a request, and basically if it says, "Can I serve this request?" If I can serve this request, then I return an HTTP handler. If I can't, I return null. And this is the nullable type that you have in Kotlin to represent something that is null or nullable. So by definition, by the type system, Kotlin requires you to define when a value can be null, and that basically removes null checks from your entire application, potentially, depending on how you write it. So what does it look like? It looks pretty much like, I don't know if you've probably seen something very, very similar in other kind of libraries. Basically, you take a path, and you can bind an HTTP verb to a HTTP handler that we had last time. So basically what will happen is the request will come into the router, it will say, if it's /echo at the start, it will return the echo handler. And that's what it will do. And then these things are infinitely composable, so you can take this routes file, this routes block, and you can put another routes block inside it, and you can just stack them in and out and in any combination to kind of build these kind of trees. And what happens is that when you fire a request into this thing, if it can't match anything, it pops out 404 at the bottom. Let's see. So one of the things we wanted to do with this was that we could actually make things very, very testable. One of the things we had before was with our Java framework, it was quite difficult. We thought it was quite difficult to test. So the nice thing about testing these kind of applications is that it's trivially easy because the building blocks are just functions. So applications are just functions. So they're just functions that take a request and return a response. So because of that, you don't need to put it on a network at all. If you want to actually test your HTTP handler, you just pass in a request, and you will, it might route it through various layers of routing, but what you get out at the end is just a response. Nothing else to it. It's all completely offline. No need to start up a server. So you can see here, so this is just a standard JUnit test, which is kind of, and because, once again, what we can do here is because echo input, where input is a request, is equal, we can just say it's equal to expected, because the Kotlin data classes have equals and hashcode methods built in that you don't have to define at all. You automatically get the ability to compare values against each other. So once you've got a function, you might want to actually put it on a network. So what we can do is, if we want to serve HTTP, we can basically take our function, like echo, and just say as server using an extension function. Thanks again, Marty, for explaining what that is. And we can just turn it into an underside server and start it, basically. So before it was just a function. This is how you actually put it on a network. We support lots of different backends because there is no coupling between the actual function and the server implementation. You can literally just switch out the word undertow for Jetty or Netty or Ktor or Apache, and it will just work exactly the same way. You can obviously also, you can configure these things, that's available, but by default, it's just this easy. So consuming HTTP, and this is where really the kind of beauty of the server, the kind of HTTP, the server as a function thing kind of kicks in, is that for consuming HTTP services, we can use the same HTTP handler interface. So HTTP handler, remember, is just a request that returns a response. So what this means is that you can actually take a server function and you can take a client and you can slot them together like a jigsaw without any, because they've got exactly the same interface. So you can slot them together without ever putting anything on a network. So you can slot entire systems of things together and never put it on network at all. So you can see here we're creating a client. We support Apache and Jetty and Sun HTTP and Sun HTTP client and OKHTTP. Here we're creating an Apache client. And how do we call it? Well, we call it exactly the same as before. We give it a request and we get back a response. And that's kind of the beauty of actually, the simplicity with which you can actually slot these things in is pretty cool. So what this actually also means is that at any point you can actually replace this Apache client with another HTTP handler which is serving it. So what you actually get is the fact that you can you have a test that you can actually completely just switch it out. You haven't changed the test. All you've done is switch out the handler. So you can take your unit test and convert it into a system test or another kind of test that talks to something on the network. No code change at all. It's exactly the same. So Typesafe HTTP contracts. So most of the time when you're kind of, we don't like to use things in terms of, as Marta said, what we don't like is actually talking about kind of primitive types. We want a little domain type to actually mean something in our domain. So, and it's very, what you have to do when you've got this kind of thing, but everything in HTTP is basically represented as a string. So, for instance, this kind of HTTP handler we've got here basically is a Bitcoin miner, and it's if you bind it to mine / the path of BTC, we can say, okay, get the BTC variable from the path that was matched. You can double bang it because it might not be there. Turn it into an int, add 1 to it, and you get a new total, which is the value of this guy that has to be a number plus 1. And then you can put it back into JSON and return it as a response. Okay? So that's fine, but we've got some problems here. So one of the problems is that, well, this thing might not be here. Right? It might be null, so this thing could blow up. It might not be an integer, so this might blow up. And then also we're returning some JSON as a string, which is, we're not saying a content type, we're not actually validating this is actually JSON. There are problems with this. So what we're actually talking about, when we want to enforce an HTTP contract, we want to enforce, and when we say enforce, we're talking about the location of the data. It might be in a path or a query or a header or a body or a form. We're talking about optionality. Is this thing required or is it optional? And we're talking about marshalling values in and out of actual strings and into real types that we can use without safely, basically, inside our code. And also, what about creating outbound messages? We want to be able to use JSON data structures, or maybe in future, we want to also be able to say use like auto-marshalling to kind of take a data class and convert it straight to JSON, so we never actually have to talk JSON at all. So there is a concept that helps us do this. That concept is called a lens. Now, lens is it's a Haskell kind of concept, and this is the definition that I found online. Lenses and their cousins are a way of declaring how to focus deeply into a complex structure. They form a combinated library with sensible general behavior, things like composition, failure, multiplicity, transformation, and representation. Simple, obviously. So let's try it again. We can make it easier. A lens is something that targets a specific part of a complex object to either get or set a value. That's all it is. It's a function, or more actually precisely, it's two functions. One function is called extract, and that takes an HTTP message and a type X, and you can extract out a class or an object of type X from that message. The other one is called inject, and that's a function that takes an object of type X and an HTTP message and returns an HTTP message with that type injected into it. These functions exist on a lens object via an invoke method. The invoke method is effectively an apply in Java, so it's exactly the same thing. So how does that look? So here's the example, an example we had. We have this Bitcoin miner that's full of danger because we don't know what's going to happen, and it's full of fraudness. So what we can do is first let's introduce a domain type to wrap our primitive. So we've got a data class called BTC, and that's a wrap around an int object. Yeah, a Kotlin int. Instead of saying plus, what we can actually do is there's a thing in Kotlin called operator functions. Operator functions allow you to do operator overloading on an object. So what we can do is say take two BTC objects and add them together, and we can add them together as if they were an integer. We already use everyone uses operator function all the time. But they're not in Java yet. They're in Scala. But the thing that people don't really realize is that when you add two strings together, you're doing operator overloading because it's a plus. We've also got this toString here that basically takes the value and toStrings it. And then let's create a couple of lenses to automatically marshal things in and out of a message. So we have a thing called a lens, and this is a path lens of type BTC. Remember what we had up here was a path parameter. So we say path.int, map it to the constructor of the BTC object, and then call it BTC. So using this definition, we can extract a type of BTC directly from the request, and we can do it safely. So how do we use it? Right, so we use it basically because we have HTTP handlers. Each HTTP handler can be represented as a route, effectively. And you can take several routes and you can test them individually because they are just HTTP handlers. You can unit test them. You don't have to put them anywhere. And what you might do is you might combine those things into an application. And the application might take a business abstraction. So in your route, you might have another service that you're talking to downstream, but you're not going to talk HTTP. You're going to wrap that little remote HTTP client in a business abstraction, put it into your route, and actually then you can actually call it as before. Now, when we have an application, we have several routes that have been combined together using a routes block, et cetera, but the application itself is also just an HTTP handler. So once again, you can reuse your test case against the HTTP handler. You can use it against the application. You can use it against the route. It's exactly the same code. We can also then do kind of using filters, we can then compose other stuff on top of our HTTP handlers. So we can say, well, I want some logging, so I'm going to log things that come in and out of my service. I want some metrics, I want to know how long things took when they went to my service. And I've also got other remote clients that I might want to talk to that are also HTTP handlers, remember, because that's what a remote client is. It's just another HTTP handler, assuming it's HTTP. And this application stack, because we can compose all the things together, we end up with another HTTP handler. So we're able to, once again, use the same test code in 3 different scenarios at 3 different levels. And the fourth thing we have is a launcher, basically. So basically, that kind of this is the thing that actually takes the HTTP handler and puts it onto the network. And so it's kind of extracted out, it's nicely decomposed, so you don't have to test if you don't want to, or you can launch it and then fire a real HTTP request into it using a remote client. So you can see here, this is a standardized server kind of a client stack that we can build using the filters. Remember that we've got, you can take one filter and we can add another, we can do then that filter and we get another filter back. So this basically looks like this. So you can build server stacks or client stacks and they all look identical because they just return HTTP handlers regardless of whether they are living on the server or living on or a client server basically. So this one particularly, it logs transactions and records metrics and handles errors, and then this is our final app. And because these 3 together are just a filter, then they don't become an HTTP handler until you terminate them with another HTTP handler. So they're completely reusable across all different things. And you can do roughly exactly the same thing against clients. You can do metrics, and you can log transactions and record everything basically. And you see here, we're terminating them here with an Apache client. So using this, what it allows you to do is actually, when you're composing your applications, you can compose them together of these 2 types of building block. And they're really easy to test. Testing both filters and HTTP handlers is really trivial. And it really gives you this power to combine these things together and reuse them in a way that's not coupled to each other. So one of the other things we decided to do was because we were using we were using JSON marshalling, and so the JSON marshalling the marshalling of lenses also applies not just to queries and headers and form fields. It also applies to things like bodies. So we can get JSON bodies and actually then just using exactly the same lens mechanic, we say, here's a request, inject this value into it, and the value is a data class, and the marshalling will be handled by the lens for us, basically. So there's plugins for Jackson and Moshi and all the other different types of things. We'll go through the ecosystem in a bit. So because it became so trivially easy to actually write servers that leverage these body lenses, we decided, well, what we can do is write really simple fakes. So we might want to talk to a fake HTTP server, and be it S3 or another downstream system. And by creating simple kind of state machines, we could actually use these fake HTTP services, which were also HTTP handlers, again. So what you can do is just put them into each other. And you can run either in memory, so you can run all your tests completely in memory with no server activity at all, which makes them really fast, and you can parallelize them because you can create an entirely different stack per test, so you can actually parallelize everything massively. And you can also, by using the filters, you can simulate failures. You can say, well, when you get this thing, actually throw a 500 instead of returning your actual response, and you can match that based on the path or any other thing that you want. So you can add failure modes to any application by just the use of a filter. So that looks like this, basically. So the application testing of all this stuff is that all internal and external applications and clients are all HTTP handlers. Obviously, this relies on everything being HTTP, but a lot of things are nowadays, so it's fine. So say we've got several applications in our stack, and we want to test them. All we can do is inject the apps into each other, and we come up with a completely offline environment that can be tested and without starting a server. And the other thing we can do is a test. We put some environmental configuration in it. It will run really quickly, and we can also, instead of using real things, we can inject fakes, or we can inject HTTP handlers that have got kind of failure modes around them. So that makes it particularly easy to test failure scenarios. So when you've got this kind of level of fake that you're creating, what you do need to do is make sure it actually acts exactly the same as your real dependency. Otherwise, it's not really a fake. It's just a kind of a vague approximation to what it is. So what we have here to prove that our fakes work exactly the same as our real dependencies is a thing called consumer different contracts. So what you can do is define an abstract test contract which has got a business abstraction, and we always test through our business abstraction. So I'm talking about S3, I've got a S3 wrapper, and it's got an HTTP client inside it. And I can test success scenarios of expected behavior in my abstract test case. I can then have two implementations of my test case. One is a real dependency test, where I'll be talking to the real server using a real remote client, be that Apache or OKHTTP or etc. And I can also, so that will automatically inherit all of these success scenario tests. I can then also test my fake as well, using exactly the same scenarios, but instead of using a real remote client, I can use a fake HTTP handler, and then with a little state machine inside it. But I can more crucially is that you can actually test failure scenarios here, because I'm testing my business abstraction. I can say if dependency Y or X blows up with a 500, what does this guy do? Does he handle it? Does he blow up? How? So that's the kind of level of testing that you don't generally get. Even when you have people, vendors supplying fake systems, they don't generally supply systems that blow up. It's not really in their interest to say, well, this thing might 500. It's not really a good look to say, oh, we also make it so it can blow up. That's kind of a bit of a weird thing. But anyway, so using this mechanism, and these will run the build, so this is really fast. It runs as a unit test. This is another thing that will run in a different part of the build. We can ensure that our fake and our real thing will act in exactly the same way, and that's kind of really important when you're talking about like distributed microservices. So lots of people talk about performance. How does HTTP fare? Well, so there's a thing called the Tech and Power Benchmarks, which is I suppose it's a community-based project that tests various frameworks and libraries to see how they react in various different scenarios. So they have some tests that create some JSON, they have some tests that read some stuff from the database, and they create some HTML. In round 16, it had over 175 entries. How did HttpHandler do? Well, it was the best performing HTTP library, Kotlin library that was actually tested, including the ones based on coroutines. So Apache turned out to be most performant, which was quite amusing to us because we didn't even write the Apache implementation. It was actually written by an amazing contributor to the library. Brilliant. And the most important thing for us is the app was the same HTTP handler and with different backends. We have exactly the same app, and we just call that extension function and pass in an undertow or a jetty or whatever. Exactly the same thing. There's no tuning done for particular backends. So you can see the full implementation here. There's like results, and round 17's now come out. It's also good for us, so that's cool. It kind of maybe looks at those concerns. That's good. So what did we gain? So what we gained was we got some pure Kotlin services. We basically removed all the Java from our code base, which was great because we didn't have these kind of clashes anymore, or the code base shrunk massively. It was a revelation. All this stuff runs without any magic and no reflection, with the exception of some of the JSON marshalling stuff. There's no reflection at all in the entire application. So it's simple, it works, it's fast, it doesn't use a lot of memory. We used these in-memory tests to run a really super fast build. So our build times came down because previously we'd have to start up a server. Maybe it's on a port that's randomly bound or something. Because you can do a lot of testing in memory, it means you don't have those problems. They just go away. We managed to do a load of end-to-end testing as well, and plus the failure testing that we managed to put in. And best of all the code is navigable in IntelliJ. So there's no annotations. Sorry, Marty. It's kind of the anti-Marty talk, really. So there's so all the code is navigable. There's no annotations, no reflection, nothing. It really worked well for us. Quick demo, I suppose. So this is if the video works, hopefully it will. Yeah, cool. So this is a small Heroku application we put on Heroku. Basically, it mimics a Dropbox kind of application. It allows you to basically it's using a templating engine based on handlebars. You can upload files. You can then delete them. You can view them. All that stuff. This is it's actually uploading this stuff back by an S3 bucket. This entire application is 30 lines of Kotlin because we provide it's an incredible simple API, but there are also S3 interactions. We don't need to use the S3. We don't need to use the Amazon SDK because we provide a thing to sign requests to S3. S3 is literally just a HTTP push or a post or a get or a delete. It wasn't 17 lines, it's 17 lines code, sorry. 30 was, the other one, sorry, apologies. So which modules does that use? That uses the Apache backend, the AWS module, some handlebars, and some multi-part form stuff. You can see it kind of, it's locked down, but you can see all the application at this link here. There are several different versions of it, including the stuff I'm just about to talk to you about. So that was great. So we started thinking, so we've got this server as a function. That's cool. We started to think, why do we even need a server? Because servers are so passé nowadays, why can't we just do serverless? And it turns out we can, because Lambda is just a function, and all our HTTP for K applications are just functions. So we wrote a thing to convert HTTP for K applications into Apache Lambdas. And because we have no dependencies, and because it's really small, and using ProGuard, you can shrink a single binary down to a really small size. And actually, what they've found is that actually the startup time of Lambdas is heavily dependent on the amount of libraries you're using. So this thing is wired in, and actually the previous example it is deployed on an AWS gateway, AWS API gateway. You just literally you can just forward the traffic from the API gateway to the Lambda, and there's a little conversion thing, which is it's just one wrapper function, and it turns it into an application. So what it means is you can take your HTTP for K application, you can test it locally, you can test it in memory, and then you can just deploy it as a Lambda into AWS. Also, native. So GraalVM, I'm sure that some people have heard of that. So GraalVM is a new kind of native thing that allows you to repackage, not just Java applications, but any JVM applications, and I think they've got, it does Python, some other things as well. You can compile JVM applications into really, really small, into native binaries, and they end up having really small sizes because, it's just like it strips out all the stuff. The startup time of these applications is incredibly fast. But there is a limitation with the native stuff, which is reflection does not work, at the moment at least. It's hard for lots of libraries to get this kind of, to leverage this stuff because they rely on reflection. Now, you can do it with mapping files and all this kind of stuff, but to be honest, it's a pain. I've tried it, it's not a great experience. The nice thing is if you stick the Apache backend on HTTP application, it works out of the box. And if you've got a simple Graal app, it's about 6 meg, and if you stick it in a Docker container, it's 9 meg. And the startup time difference between, I think somebody did a thing online where they looked at the different startup times, and it was like 50 times better, quicker to start up, or something like that. So if you're concerned about this stuff it's all quite new, but if you're interested in that stuff, check it out because it all works. So one other thing is kind of final thing. So I'll let you get back to your beers a bit soon. So we thought the combination of server as a function, that these two types of function is really powerful. We wanted to show you what you can do with literally a couple of lines of code. So this is a static directory server, basically. So this will start up. It's like the Python simple HTTP server. Obviously starts on in the current directory it's running in, but that will serve files in from a running Kotlin app. This thing is a proxy that will record all traffic that goes through it to disk. So it will basically serialize all the traffic into this store directory, and it also has no dependencies because we're using the Java HTTP client that's on HTTP. That all comes bundled with the JVM. There's WebSocket as a function as well. So testable WebSockets is something I haven't seen anywhere else. So we also model WebSockets as an entirely testable entity in exactly the same mechanism using as functions, basically. So it means that you're not, if you want to test WebSockets offline, I'm happy to be wrong about this. I've never seen it done offline. We can do it offline. This one you kind of connect to it and it sends you like the time every second, basically. If you wanted to take this traffic that we had recorded and play it back another server, you could use this. This is a client, and then basically it takes the store, gets all the requests, and for each one, it posts it back at a server, basically. And the fifth one, this is a chaos proxy. So what this does is inject random, what you can do is inject random traffic into, you can put this proxy between two services and it'll inject random behavior. This one, in this case, it's latency between those two services. So we define a load of different behaviors that you can add. You can make things crash, you can make them to 400s, 500s, you can make them run out of memory, all this kind of stuff. And remember, you can also add this stuff to any other, this is just a proxy, you can also add it to any other running application. So you can see what happens if my thing runs out of memory, what happens if it just stops, which is something that you might actually want to test when you've got a distributed system. Last word about the ecosystem. So the HTTP core library is 700K. It's got no dependencies, and it will run with the Sun HTTP client and the Sun HTTP server, which these two, we've written this one, and the Sun HTTP server comes out of the box with the JDK, and it starts and stops really quickly, so you can use it for really kind of low effort, minimal, no dependency testing. We support these servers, so these are the backends, so obviously Netty and Jetty and stuff, and there's the AWS Lambda stuff. There's some WebSocket client and the other HTTP clients, these are things. These are the automatic marshalling format libraries, I suppose. So there's XML and there's some JSON ones. Templating libraries, we picked a few. There've been a couple that have been contributed, so that's amazing. Testing is very important to us, so we've plugged in things for testing. We've got Hamcrest matches for anyone that uses Hamcrest. This is Hamcrest with a K, which is the Kotlin version, written by the same guy. WebDriver, so you can test web applications completely offline because it's just an HttpHandler, so you just plug it in. Approval testing, which is my latest thing, and Chaos Monkey, which is the addition of that chaos filter. And then we've got some random other stuff, which is kind of operability. So there's some cloud-native stuff for apps in Kubernetes, the AWS request signing, some resilient stuff. We provide OAuth 2 servers and clients, so it's really easy to connect to other OAuth 2 services. And OpenAPI, which allows you to basically fully generate OpenAPI Swagger documentation, including like models and all this stuff directly from the code. So one of the differences between how it's done in HTTP and other libraries is that we generate it from the code, so it will never go out of date, and it's not done via some documentation that can go out of date. And that's about it. Thank you very much for listening. If anyone wants to check it out, please go to one of these things. Are there any questions?